Yeah, so the next particular session is on an introduction to Microsoft Machine Learning for Spark. And session we'll learn about we'll make a simple Spark project to create a deep image classifier with transfer learning. So now that's one more another term you have heard for the first time today, and we'll talk more about what is transfer learning and everything, and distributed computing frameworks using Apache Spark and all these things. And for this session, Priyanka Shah which will be joining us. So yeah, thanks a lot for joining, Priyanka. Is Priyanka on the chat? Because I'm not able to. It's loading. Let's give it a few seconds.
Yes, Kunal, I'm here.
Cool. Alrighty, yeah, thanks a lot for joining, Priyanka, and really looking forward to this particular session. Would you like to tell us a little bit more about yourself?
I hope I'm visible,
Yep, can hear you. You are visible as well.
Yeah. Hi, Kunal. Hi, everyone, and thanks for joining us. On this Global AI Student Conference. Kunal, about me, nothing special. I'm a passionate techie, Microsoft MVP for AI, and routinely interested in investing myself for machine learning, especially related to the Microsoft technology stack. So as there are quite a bit of offerings out there. Like you have machine learning studio, you have cognitive services, you have Databricks, and you have Synapse Analytics, and you have MML Spark. So usually I get a lot of questions about when to use what tool, right? And MML Spark is something which has been used in many of Microsoft's own initiatives, like the Snow Leopard project, especially with the deep learning and image classification and GANs, like generational adversarial networks. So all those sort of things. So I thought it would be a nice topic, and that MML Spark is something which is not often talked about, although it has a lot of capabilities and can do lot more things a lot faster. So it's something which is not talked about a lot as compared to the other Azure Microsoft offerings. So I thought it would be a good thing to get started, get people's interest on this, and uh, have something come out of this.
Yeah, most definitely. Really looking forward to it. And the stage is yours. Take it away.
All right, just I'm sharing my screen. Just let me know if the resolution and the slides and all are clear or not. Sometimes,
Okay,
because I'm
will do.
using Surface Pro, so could be an issue sometimes. Not sure. Is it?
It's visible to me.
Is it okay?
Looks perfectly fine.
All right, so we are all set. Do let me know if I'm running out of the time limit or something. So I target to finish off in like 25 minutes, and then open for questions.
Yep, sounds good.
All right. Okay. So let's begin. Hi, everybody. This is Priyanka here, and as I said, we would be talking about Microsoft Machine Learning Spark, which is MML Spark for short, right? Quickly about me. So as I said, I'm a MVP for AI, and you can always connect with me on my Twitter handle, which is at FuzzyMind1. Briefly, the agenda for today would be introduction. We will be seeing out about Spark, especially then Azure Spark, the features, the common question which we get, Spark versus Databricks, and then you will see use cases and a demo. All right. So we talk about Spark, right? So very simply put, if I had to explain about Spark, that would be another session altogether, wherein we compare and contrast Spark and Hadoop and Spark Yarn and clustering and stuff. So very briefly, we can define Spark as a framework which can quickly process lot of humongous data load. So Spark is immediately associated with big data, especially in organizations where you get like terabytes, petabytes of data and stuff, and quickly processing those efficiently, distributing the workload. That is what Spark is basically for, right? And it will distribute that workload across multiple computers. It can form geographical clusters and also efficiently distribute the processing of the data load, right? And when we talk of huge data, distributed computing, these are few of the key terms, qualities which we are immediately used to associate to machine learning world, right? Because you'll get humongous amount of data and you have to process them efficiently and stuff, right? So Apache Spark, it consists of two main components. So you have a driver, okay, which is like the master, which is controlling all, like which node to distribute, which node should be up, which node should be down. It has the knowledge of all the nodes, right? So you have a driver, which is like the master, and you have executors, which are like the slave programs, okay, or the jobs which are executing. So imagine that, there's something at the top, a controller on the top, that is assigning the data load to your what you can say, your other machines, the executor machines, and then telling them that maybe you execute the first 5 TB of data, or the first part of the file. So typically, people who have experience in Spark, they will see that whenever you process a file, right, you will typically get part files, like the job which is executed, they will make part files like dot part one, dot part two, those sort of things, and then at the end they are combined and then sent for processing, or those individual parts could be sent for further processing. So depends on your job requirement. So very just reiterating the fact, like Apache Spark, it's like, just imagine that you have a controller which is distributing your workloads quickly across multiple nodes or clusters, could be geographically distributed, could be scaled up, scaled down as per the necessity. And this master slave kind of configuration, or the executor driver kind of configuration, will require some sort of a mediator, right? So how to distribute the job load, how to check whether nodes are up, down, more nodes needed, and some sort. So we have processing platforms which provide these sort of mediating tools, and MML Spark, which we are going to discuss today, is one such cluster management platform. All right. So yeah, which brings us to what is MML Spark. So which is Microsoft Machine Learning for Spark. And it is, if you look at the documentation right on the website, it is defined as a fault tolerant, elastic, restful machine learning framework. Why restful? We'll come to that, because most of the cognitive services offerings which Microsoft has also can be efficiently called into your the MML Spark platform. And also, you can call a lot of other APIs out there very conveniently into your MML Spark programs here on your Spark on your MML Spark notebooks, right? By Spark notebooks. And then it expands the distributed computing framework of Apache Spark in several new directions. So what does it do? What all new dimensions it adds is, like, apart from using the rich machine learning libraries of Spark, right? So it also adds LightGBM, which is like, the light gradient boosting machine algorithm, right? Which has been proved phenomenally accurate for a lot of classification, clustering, regression, those sort of scenarios. Okay, then Wappel Wabbit is their text analytics, right? So analyzing text and efficiently doing sentiment analysis, much more word semantics. Okay, OpenCV is computer vision and isolation forest. So all of these and much more you can do in MML Spark. So I have embedded links to all of these, so you can just go ahead and learn more about it, because each of them, again, as I said, is an extensive project in itself. If talk about LightGBM, or talk about Wappel Wabbit, or computer vision. Okay. And MML Spark, what it also does is, if you talk about the features of MML Spark, it brings into networking capabilities to the Spark ecosystem. Okay, so which means when we talked of RESTful, right? We talked of RESTful. So what RESTful means is that users can embed any web service into their Spark machine learning models. Okay, so the web service which I'm talking about could be your cognitive services which you have created, or it could be your machine learning model which you have deployed on your AutoML, right? And you have deployed it on the Azure container instance or somewhere, and then ready to use it, right? So you can embed any web service into your Spark ML models, And then because Spark, when you talk of Spark and huge data and clusters, and you can also then network between your Spark clusters very easily. Okay, so this is what it also provides easily for us to consume Microsoft Cognitive Services. Okay, so Microsoft Cognitive Services, if you briefly see, we'll see a small demo of that. So you have a lot of vision, speech, text, decision making related ready to use AI programs. Okay, so which means you can so let's see, like just one instance of cognitive service which if I had to give you would be, let's say, if you're talking of text analytics. So this is some, we are talking of something like Saturn is the planet and stuff like that. So immediately what the cognitive service itself does is, when we are consuming the cognitive service, it's like a AI packaged as a program, so AI as a service, right? I'm not doing anything here. So I'm not writing any algorithms or using any gensim or using any TF IDF and those things. It's just the text analytics as an offering given to me. So I just feed an input paragraph to that cognitive service, and in return it gives me keywords, key phrases from my paragraph. Then it could also do entity linking. Okay, it can also identify the sentiment of my text. It can also identify, like for example, what personally entities, personally identifiable entities like celebrities, landmarks, or geographical locations, geospatial indices, and stuff like that. And then it will give you further links for you to refer. So Bing entity search on each of the personally identified entities it has marked down in your input. So this all these things, it's like an AI which has already been running, and it is packaged as a service given to you. You can consume it using your HTTP endpoints. So that was a very, very, very brief overview. So I have embedded the links, and you can just go and have a look at all the cognitive services which are AI as an offering, which are given to us by Microsoft. So all these cognitive services also you can easily embed into your ML Spark ML models. Okay, and then of course, like because Spark projects are associated with faster processing and absolute, like, sub-second latency, millisecond latency, so very fast. So just imagine, like, you have your huge data loads being processed in a matter of seconds. Okay, so these are the brief features which we can leverage the power of cognitive services on Spark. Cognitive services in themselves are, a very, very powerful, very efficient, very accurate, and we can bring those capabilities to Spark as well. Stress-free serving, then light GBM boosting, light fast gradient boosting, broad language support, which means it can support Java, Scala, Python, R, .NET, I mean ML.NET as well, C# .NET, fast and sparse text analytics using Wowpal Wabbit. Okay, scalable deep learning, because we are processing huge data loads, and Spark ML is capable of is normally used in image classification, transfer learning. So this is where you come to scalable deep learning. So you have your Azure data science VMs or Azure deep learning VMs, where you can download these Spark libraries and then prepare your deep learning projects. Okay, distributed microservices and large scale model interpretability. So these are all the features of Microsoft machine learning Spark. So just imagine that it is making the best of both the worlds, taking the best from Microsoft offerings, okay, and then Spark offerings, combining them together, on top of it adding RESTful capabilities, networking capabilities, and then of course all the other benefits of Azure as well. Which brings us to Azure Databricks versus MML Spark. So if you look at, as I was saying earlier as well, we look at the machine learning ecosystem of Microsoft, and you have a lot of offerings there. All right, so you have machine learning cognitive services, you have Synapse Analytics, you have ONNX, which is Online Neural Network Exchange, Databricks is there, MML Spark is there, and lot of things out there. So basically, basically this sums up, like what each offering can do and what each offering is used for. So the most common question which we get is Databricks, which is already operating on a Spark analytics platform, Spark based analytics platform. So how different it is from MML Spark? All right. So if you look at Azure Databricks, it is an Apache Spark based analytics platform, which is again operating on top of Apache Spark. So you build and deploy models and data workflows using integrations with open source machine learning platforms. Okay, so that got truncated off, the text got truncated off, using integration with open source machine learning flows, ML flows. And if you look at MML Spark, create and deploy scalable machine learning applications for Scala and Python. So more or less, Azure Databricks also, most of the time we are writing applications in Python and notebooks in Python, and utilizing the capability of Spark for processing huge data loads. And MML Spark also does the same thing. Okay, but here, I mean, we are heavily using the Spark machine learning libraries as well, and just take care of the keyword Scala. So if your programs are very heavily written in Scala, then probably MML Spark would be a better choice. And then again, if you want to leverage on the existing applications which are there, like Wapal Wabbit is there, LightGBM or Isolation Forest, and all those which are already the existing projects, GitHub projects, libraries of MML Spark, you can better off have something which has already been made ready for you. You can leverage on top of that. Okay, so you have even on your Azure data science virtual machines, right? So once you have your data science VMs or your deep learning VMs, on top of that also you can have all these Spark machine learning libraries, and then continue to build your projects. Okay, continue to experiment with your projects. Having said that, sorry. Yeah, having said that, let us look at quickly the demo where we are using MML Spark. Okay, and let us see also how quickly to run one classification algorithm for classifying your Amazon text ratings. So there'll be two things. One is a Gen Studio, which is like a demo which we will do for image analysis. Okay, and then there's another one which we will see how to actually run the code on MML Microsoft machine learning, so MML Spark libraries, using MML Spark libraries. All right, so we will be creating Spark pools and stuff, and we'll be running it on a PySpark notebook which is created on a Synapse Studio. Okay, so one will be a demo which is already there. The source code is given there. It's on the GitHub. For that, it's already out there for everyone. And the other one we'll see is like a proper project with MML Spark. All right, because if we were to start doing the transfer learning or image classification right from scratch with MML Spark, it would take a lot of time to show you the actual training and validation models and stuff like that. So let us go with something which is already there, which is baselined already, and let us try to see how powerful Spark workloads and MML Spark in itself can be. Okay, so let us look at this one. Okay, sorry. Yep. So yep. So this is a project which is called Gen Studio. What does it basically do is it is experimental collaboration across the Met, Microsoft, and MIT. It's there. Okay, and then what the source code is also here. So I have embedded the link of this in the at the end of the PPT. You can just go ahead and see the source code of this project. So we will see the demo here. What it basically does is these are the pieces, images of actual art pieces that have been sourced from the Met. Okay, so this is the Met gallery, right? And these are the actual images of antiques, paintings, museum artifacts which are displayed at the Met. Okay, so now what we are going to do is, so let's say when you have we'll select a particular image here. All right, so here you can select categories, armor, events, and stuff like that, vases, teapots. So let us maybe look at this particular wine glass. All right, or yeah, just let us say that, and then we will enter the AI Studio. Okay, so what happens is the image which we have given here. So there's a concept called as GANs, which is generative adversarial networks. So basically what GANs are trying to do is it will always challenge, like, one particular image, whether it is original or generated sort of thing. So it's always a challenge between, so GANs always, to try to establish the authenticity of an image, whether it's a true or fake. We are basically using GANs. So whenever you do a select a model, so we selected an RPCR goblet, and then the GAN generated a sort of toned down image of that. Okay, so try to generate a challenge image of that. Okay, so the goblet, and this is the challenge image of that goblet, which is like a scaled down version, with will you'll associate terms with PCA, principal component analysis, and those stuffs, reducing the dimensions and image, I mean, just giving us the basics of the image sort of things. So yeah, so you have this challenge image generated, and then out of that you see that it has given you a sort of connection between few images that it identifies, and then you can have explore similarity. Okay, so let's say if I choose this particular the challenge image, and if I want to see whether it is similar to the original selection or any of the others which it associates itself with, right? So if I see this, right, whether it is if this image, so if so this was my original image, right? And then if I see that how similar it is to all of the other things, you can see that it is trying to morph them into possible shape of the GAN which was generated. Okay, so see this, and then you can have yeah, and then if you look at here tab 2, yeah, so I'm just trying to explore the space between the artworks, right? So whatever the GAN was generated, it I'm trying to map the space between my GAN and the other images which are out there. Okay, and then mm, yeah, okay. And then there was another, okay, here, yes, combined features. So in that combined features, if you see, right, so this was my GAN which was generated for this goblet. And then if you see, I can choose these other objects which it has found more or less similar to this particular GAN. Okay, and then I can try to morph them into increasingly these objects. So I can say include more of these features, include less of these features, include more of these features, and you can see how the GAN is changing over here, right? So just try that. Maybe I want the GAN to have more features of this particular object. All right, you see it keeps on changing. You see how the image is morphing now. The shape is coming more closer to what features I want to see into my GAN. Let us try to make it more like a teapot, and you can see that how beautiful it is changing its shape and trying to incorporate the features of the teapot more, look more like the teapot, or try to make it look like an armor, more like an armor, and see how the GAN is morphing here, and trying to match itself to uh, closer to the selection which I'm doing, like, explore combine features. So combining features from similar looking, or maybe, possibly similar stuff. Okay, and then maybe, less, or you can also do that, less of these features, more of XYZ features and stuff like that. So yeah, so you can just imagine and how quickly you can do all these things. So that's the beauty of using MML Spark. Just imagine the amount of images it has to be trained on, and then, immediately trying to manage the space between the images, space meaning the dissimilarity or the similarity quotient between the images. And for all these things, they are operating using the MML Spark libraries. Okay, so very quickly we will see this one demo for classifying Amazon reviews. Okay, so you have reviews out there for books on Amazon, book reviews, and then, we are trying to read those reviews and classify them depending on the text analytics, right? So depending on the few keywords, we are trying to classify those images which are so not images, the text reviews between greater than rating 3. Okay, so greater than 3 out of 5, we are trying to classify. So trying to gauge whether that review is greater than 3, right? So I have already imported pandas here, and I'm reading that into the data from the, the reviews. Okay, I'm reading that. Okay, and then what I'm doing is, so then I'm featureizing the text. Okay, so using MML Spark. So these are the MML Spark libraries. So this is MML Spark featureized text library I have used, and have imported the text featureizer from there. Okay, so you do all the TF, IDF and stuff like that. Okay, and then I'm processing what are the features and what is the label which I have to predict, and then I'm dividing them into train, test, validation data sets. Okay, and once I have done that, I will what I'm trying to do is I'm trying to get the best model, because it's a classification. My metric is AUC, right? Area under the curve. And then from that, once that it's executed, okay, then what I'm trying to do is from the trained model, I'm trying to get the accuracy, right? So model accuracy is 84.67%. So all of these things, I have used, I'm using the MML Spark library. So there's a rich set out there. You have text featureizers, you have other image classification libraries, you have LightGBM, lot of projects out there. I've embedded all the links here in your for the references. All right, so I just wanted to show you, like, even for the amount of text reviews which you had to read and mine and derive the derive the sentiments and then classify them. It just took a matter of like few seconds to process your loads. All right, so I had created a PySpark notebook on Synapse Studio, okay, using Azure Synapse Studio, and that PySpark notebook is running MML Spark. If you're using your normal Conda platforms or Python platforms, you have to first install PySpark and then get started with your MML libraries. All right. So yeah, the demos which we saw, and then these are the Spark references which I have embedded. So this is the Gen Studio demo which we saw for the GANs. Okay, then this is the GitHub where you find all the Spark projects, libraries which you can try. Warpal Wabbit is there, text analytics using Warpal Wabbit, LightGBM, image classification. Okay, also a few libraries using to install on Azure Data Science VM for deep learning, and these are the AI demos which you can try out for cognitive services. So with this, I'm open for questions, and I hope at least at the surface level it makes you aware of the capabilities of MML Spark and in what scenarios it is being used for. So one a very specific scenario which it is being currently used for is the mapping of the snow leopard. So in the snowy region, now mapping the snow leopard and tracking the movements of the snow leopard for its conservation habitat and stuff. So they are currently using image classification with MML Spark. You can go out and check out that project also, snow leopard conservation. It's also there in the GitHub repository which I have shared here. Yeah, having said that, I'll be open for questions.
Thanks a lot for sharing, Priyanka. That was a really amazing presentation. Gave a lot of insights regarding that, and I loved how you compared, so many offerings that we have to offer, because it often comes in my mind as well. You have so many libraries and frameworks, which one to use when. But yeah, I see we are a little short on time over here, but they can be like there's like I believe you'll be also joining the cafe where many students will be interacting and sharing their additional questions. So once again, I thank you for joining, and maybe we can learn a bit more about Spark at the cafe and have some nice conversations over there. Maybe you could elaborate a bit on how it was used in the GAN demo. So many things we can definitely looking forward to. Yeah. So yeah, everyone, students who are joining, in case you have if you want to learn more about it, you can join the cafe, ask your questions over there. But once again, it was a great presentation, and yeah, thanks a lot for joining, Priyanka.
Thank you, Kunal. Have a nice day, everyone.